The swimming pool. How does a swimming pool work in a building? It is of utmost importance that swimming pool operation be strictly adhered to when dealing with pressurization, air temperature, water temperature, and relative humidity control of the pool. Swimming pool regulations state that the normal desired controlled conditions are pool air temperature 87 Fahrenheit, pool water temperature 85 Fahrenheit, pool area relative humidity 50% RH. It is necessary that the pool air temperature be 2 degrees higher than the pool water temperature. This will inhibit condensation forming on the walls and windows. The pool area must be controlled at a negative pressure relative to outside and to adjacent areas in the building. Air must migrate from outside and from adjacent areas into the swimming pool area. If swimming pool operation regulations are not followed, the pool will be controlled at a positive pressure and air will migrate to outside from the swimming pool. This will amplify any building structural and envelope deficiencies. Condensate will form in the outside of the perimeter wall and cause water to drip down the wall. This will cause deterioration of the building wall. If swimming pool operation regulations are not followed, the pool will be controlled at a positive pressure and air will migrate to adjacent areas in the building. This results in the growth of bacteria or mold above the suspended ceiling and in enclosed spaces with poor ventilation. Bacterial mold is most detrimental to human beings. For bacterial mold to grow, 3 conditions must exist. Heat is required. Moisture is required. Nourishment is required, and this can be any construction material that contains minute amounts of starch. Normal ambient air relative humidity levels in a building are 30 to 35%. Swimming pool ambient air is controlled at 50% relative humidity. The air system which serves the pool area must be air balanced to certain design criteria to ensure that the pool area is negative. Supply air to the pool is 2,000 cubic feet per minute. Return air from the pool should be 1,800 CFM per minute. Outside air to the pool should be 200 CFM. Exhaust air from the pool should be greater than the outside air, perhaps 500 CFM. The rate of exhaust can be set to achieve specific air changes in the pool based on the rate of exhaust air volume of the pool room. It is suggested that exhaust air fans should be equipped with a fan speed control to allow for correct air balance of the pool area. The pool return air grill should be of an adequate size so there is no high velocity or noise at the grill. If the air volume returning through the grill exceeds 700 feet per minute, there will be noise. The pool air system will consist of return air grill, outside air intake, cooling coil for dehumidification, reheat coil, supply fan, supply air diffusers, automatic controls. It is important that the primary side of the heat exchanger, which heats the pool water, be supplied with boiler water at a constant temperature of 180 Fahrenheit. It is also important that the air system reheat coil be supplied with boiler water at a constant temperature of 180 degrees Fahrenheit. The boilers supplying the heating water cannot be controlled using an indoor-outdoor reset schedule. Using this control theory, as outdoor air temperature increases, the boiler supply water temperature decreases. This is not acceptable for pool systems. I hope that helped. Bye now.